Hello, everybody. I thought I would share some of my experiences in this fantastic course as I've been digging more into machine learning, not because I'm trying to be a data scientist or that I aspire to be a data scientist or anything of the like. I really don't, and it's not because I'm trying to get out of it. Primarily a developer, a quote unquote full stack developer with varying interests in working in cloud technologies, AWS, some DevOps, things of that nature. Again, machine learning is something that I've known about, but I haven't really dug deep into it because, to be honest with you, like I said in one of the previous videos, it was the mathematics part of it. It had been a while since I took a lot of the engineering math that I took in college. Um, but in the last month or so, I've really decided just to go and try to plow through some of those gray areas. And I found out that if you want to be, a developer like myself, who understands enough about machine learning to assist other experts, or to be like an assistant, or to talk, discuss about it in meetings to determine whether it's viable or not. Um, that's pretty much been my goal. I've taken a few courses, online courses. I'm a firm believer in online courses and self-study, things of that nature, to learn machine learning. And one of the very best ones that I have taken up to date right now is this particular course. And like I say, I can't recommend it enough. I did another video on it before, and I will say I reached out to the discussion group and actually got correspondence. I went ahead and emailed support to the Super Data Science team, asking them if it was okay for me to show some of the content, some of the examples from their course in these and future videos, as long as I give them complete credit and as long as I, continue to recommend this course, which I totally am on board with. And they were kind enough to say yes, and that it was okay to do that. However, I'm still not going to really, how do I want to say this? I don't want to give away too many of their details because I really do feel that everyone should buy this course. So in some of the labs that I've taken, I've included a lot of notes and things of that nature. And I probably won't be sharing a lot of those notes. Instead, I'll be giving more of a high level. I'll be running some of these examples. But it's not to withhold information to you guys, just to be a jerk or anything like that. It's out of respect. And I'm sure you'll understand. It's out of respect for the authors of this course who were kind enough and their assistants to let me show this course. Because like I say, I really do want you to buy this course. And so this course, is really taught a bunch of the algorithms, in addition to the algorithms and certain, types of ways to use machine learning with classification and regression and other things, and clustering. They also add some bonuses, and I found the natural language processing one to be really cool. And by the way, they give their examples to you, the labs and stuff like that in Python and R. I chose just to do all the Python examples, so I skipped all the R. It's the same labs, just with two different languages. In the future, if I ever do have a position that requires me to learn R or something like that, no problem. I'll just go back into this course and do those examples in R. So I completed this whole course and went through all the Python examples and skipped the R. What I wanted to kind of demonstrate in this video was natural language processing and why I think it's really cool. So without further ado, so the natural language processing, like I said, it's a part of computer science and AI, and it involves interactions between computers and us, using natural languages. So some of the examples are, when you're talking into your iPhone or your device, you know, something like Siri, and it basically translates what you do to text spoken. That's that's known as they use NLP algorithms, natural language processing algorithms. Same with basically when you're typing in text, kind of like a bot. If you have a chat bot at work, you know, where it says, "Hi, how are you doing? How may I help you?" And then you type in some information, you know, about, you know, where is this quote unquote server located for this application. It's going to interpret your typed text, and it's going to more times than not understand what you're saying. If it doesn't, it's going to say, "Can you repeat that in a different way?" Those all go through a series of very complex natural language processing algorithms. And there's a model called the Bag of Words model, which this particular course, and I'll just kind of show you a little bit, uses and demonstrates. But like I said, NLP's been around literally since the 1950s, and then, you know, basically it started making more and more advances in the 1990s. But some of the use cases for that would be sentiment analysis. So based on text or your spoken words and stuff like that, it can identify which mood you're in, whether you're happy, whether you're sad, whether you have a positive opinion about a review of a restaurant or a negative opinion. You know, it basically is there to answer questions if you speak or type in a question. Like I said, that's speech recognition. It can also do document summarization, you know, so what I mean by that is if you're typing in a review of a restaurant or something like that, it may be able to determine whether or not your review is a positive one or whether it's a negative one. So it'll build that model on existing reviews, and then when future reviews come along, it'll be able to determine with certain accuracy, hey, this person just typed in a positive, or this person just typed in a negative review. So one of the cool things about this course is they use what is known, they use a technique, a well-known technique called the Bag of Words model. And it's, you can look it up here, you can see it's on Wiki. And it's a very popular natural language processing model. And it's used to pre-process text to classify. And so it'll basically, based on that text, it'll take your document or your review and split it into a series of translations. It'll reduce that document and filter out a bunch of the junk or redundant words. And what you're left with is phrases that are stemmed. And I'll just kind of get into stemming a little bit more in just shortly. And it'll be able to determine whether or not that's a positive or a negative review. So it involves a vocabulary of known words as well as a measure of the presence of known words. So, you know, like you say, here we got right here, and then we've got this text right here. So what ends up happening is, you know, these get translated into an array here. But even more so, you know, the process of stemming, which is pretty interesting. So I'll kind of get into that in a little bit. So what I am going to do, I started up Anaconda, and I showed you Anaconda in a previous video, the starter thing, and I launched Spider, which is the Python development IDE, and when you install that, it comes pre-packaged and preloaded with all the proper Python libraries that you need for machine learning, NumPy, Matplot for graphing, Pandas for spreadsheet massaging, and things of that nature. And so this really cool example, so what they give you in this from the course is they give you an existing data set. So you think about this, if you will, as it's a data set of history. And think of this as a restaurant for the most part. And, you know, it captures all of the people's reviews. And the second column right here is a 1 or a 0 indicating that this was a positive review they left or a negative review that they left. And basically, so you had, you know, imagine if you a website or a survey or whatever where they were typing in the review, and at the end of the review, they were checking whether they liked the place or didn't like the place. And so the whole idea behind this is, we actually want to be able to take this known data, this is a negative review, this is a positive review, and we kind of want to package all of the words that for all of the positive reviews. We want to kind of count, package, group, categorize, and weight all of the words for the positive, and we want to do the same for the negative right there too. So if you look in this example, you got a 0. It could be because potentially due to the words worst and disgust, because if you look at the other zeros out there, there may be more occurrences of the words worst and disgust. And by the same token, for the positive, for the positive reviews, in this example, potentially stars could be a weight for positive, as well as receives. Same with right here. When you see definitely and then go back potentially. Glad is another indicator. So you can kind of see what's going on here. 0 could be potentially because of the number of phrases, number of words here. For other negative reviews, apparently there may be some words in here that occurred more in those other negative reviews, which could be the words like nothing or took over, things of that nature. So the idea behind this is using this particular algorithm in this example is we're going to read this into a spreadsheet, and we're going to create our data set. And so for the most part, if you take the course, and like I said, I'm omitting my notes on purpose because I really do want you to buy the course. But if you take the course itself and go through these examples, you can see we're using the Panda library to read the data set. So check this out, which is really cool about Spider is you can go ahead and use the Panda library to read that data set. You can highlight a section of the code and just only execute that section right up here. And lo and behold, in my variable explorer, you can see it just created a new data set variable, which is mapped to here. So what we've got now is you can see this spreadsheet files, thanks to Panda and all that. What you're looking at for the most part is, right here, we've got the first column, which is a review. It says, wow, love this place, and a liked. So you can see this has got 2 columns. You got the text, and then you've got the liked, whether or not you like it. So we basically are reading that into a data set. And of course, you can specify your delimiter, which is a tab instead of a comma, because you may actually have commas as a part of your text inside of there too. Now we actually want to go through a process of stemming and cleaning. And it's important that we clean because we don't want to load too many of these keywords into memory. So we want to clean the text to make it easy. And what that basically means is we want to go through our data set. And if you look inside of here, you're going to see a lot of redundant words like the and. You kind of want to get rid of those kinds of things, including even this ellipsis right here. So that's kind of the idea of stop words and stemming. So basically, stop words is a lot of the redundant words, things of that nature. Stemming, on the other hand, is another interesting concept, and you've got the Porter Stemmer library that'll help you do that. And the idea behind stemming is the word loved, for example. The word loved indicates positive. So that's probably the reason why we got a positive review right here. We will understand as we go through, the word loved probably appears more than once in many of here, like those kinds of things. Stemming, instead of storing loved and love and loving and those kinds of things, they all mean the same thing. They all have a common root. Think of the stem as kind of like the stem of a tree or the stem of a branch. You could have a love stem. I know it sounds kind of corny, but the branches that break off of it could be the word love, loving, those kinds of things. You get the picture, but you'll see what will happen right here with an example. But stemming is going to, look for all of the shall we say, relationships for a given word, and it's going to reduce them all to what their quote-unquote stem or base is. So not really going through a lot of this stuff here. And again, if you take the course, they explain it in great, great detail. That's why I can't recommend the course enough. I am executing this piece of code right here. It's still running down here. There we go, because it had to download the external library for the stop words. If you take the course, it'll explain in more detail what the stop words do. Again, I'm omitting that just for, because I do want you to take the course. So we end up with some more variables. If you look right here in the Python code, and like I said, this is a lab that they walk you through and give you a complete deep dive. And if we take a look at the review now and the corpus is what's really kind of interesting right here. The corpus basically is a one-to-one array mapping from the data set in here. So by going through the process of stop words and stemming, you can see what it did right here for the first review. It took the phrase "wow, ... love this place," and replaced it with this. Crust is not good. The stemming library replaced that whole phrase with this. It even uses its own translations, like not tasty and blah, blah, blah. You can see it used this. The idea is some of these patterns that you see on the right here, they are common stem patterns, which, they go through all these reviews. Like if we look at 109, so good. For there, it just basically the process of stop words and stemming just eliminated the exclamation points right here. But if you look here, like good prices for 114, the process of stemming replaced prices with price, because you may have other reviews out there that have price or pricer, things of that nature, and you don't want to store all of those redundant words to associate a rank with them, since they all pretty much mean the same thing. So that's important, because this will help make your model perform better when it's analyzing new reviews as they come in through the process of stemming. And so that's what's going on in the corpus thing right there. And, as far as the review is concerned for each one of these, that's just a temporary variable. So it just goes through the loop here as we're trying to create that new corpus. This is going to be equal to the review of the last one. So you can kind of ignore that. But what we end up doing at the end of the day then is we end up working not off of this data set right here, but we end up working off of the corpus, or translated, when it comes time to actually go through our test set or try to do predictions right there. So that we just basically cleaned out our data set and cleaned our text. And again, like the stop words is the list of irrelevant words, and we ended up stemming it right there. So the next thing what we want to do is, by using the bag of words model, which goes right here, we're going to create a corpus, or we created the corpus, which is 1,000 clean reviews. And what we're actually going to do there is we're going to create our training set and our test set. So given your input data set, which is right here, what we want to do, that is a data set of real, actual, live historical data. So in the real world, that data set's going to be much bigger than 1,000 entries. But like I said, this course is so awesome that it's good enough for just to show you how the bag of models works. We have 1,000 entries right here, but we want to train our model usually with 60 to 80% the size of the incoming data set. And then we want to, and that's randomly selected. And then we also want to randomly use the other 20% or 40% or whatever as our test set. So again, we train the model with random, shall we say 80% or whatever, could be 75% of that set. And we run it through the algorithm and stuff like that so that it can learn. So we're basically going to take 75 to 80% of this data right here. And then the other that's left over, we're going to validate whether or not the model that we trained with that other 80%, we're going to try to get an accuracy rating, whether, hey, is the model 80% accurate? Is it 85? Is it 86? And you know what? In many cases, 80%, 85, or 86 is darn good. It's a heck of a lot better than 0%. You know, so there's that old saying, and they even mentioned it in the course too, there is no such thing as a perfect model. There's just that one model might be best suited for a particular case or whatever. So having said that, you know, now that we've got our corpus and things of that nature, we're going to go ahead and, you know, we're going to go ahead and create our X data set and our Y data set. So let's go ahead and execute this piece of code right here. When we do it, as you can see right here, it creates a Y, which is going to be from the liked column right here. And these are randomly chosen. And then it's going to create an X, which, you know, is going to be an X column right here. And what is this, you may ask? And I won't get into too much detail, but basically, this right here is a count of all of the occurrences. So what the bag of words model does and stuff like that, it's literally going to count all of the combinations of the words that you have in this data set, and it's going to create a column for each of those words. And for each of those words, it's going to give you like a count. So you're going to have a sparse matrix and quite a bit of this. Now, I know it looks like you're looking at an awful lot of zeros here, but if you kind of scroll right here, you can see that there's a count for column 49, which is going to be one of these particular words right here. We have a count of 1. So there really are values. You can see 1 here for those two. You can see the occurrence of 1 there. You know, scrolling up there, you may see some other cases where, let's see what we got here. So I kind of maximize that. So each of these are a review. Remember how we have 1,000 reviews? So each line here is 1 review. And we actually have like literally, we could have like up to like 1,500 columns. It just gets bigger and bigger and bigger here. And like I said, it is a sparse matrix, but what it's doing for each review, it's counting the number of occurrences of a specific word. Like if you look at line 760 or column 760, we have a lot of reviews out there that have at least 1 of that particular word. So depending on the outcome of that, and what I mean by the outcome of 760, if you take a look at Y, on a certain line here, you can, for column 760, for example, review number 19, you could see that the outcome of that was 0. So for this particular review that had 1 occurrence of that word, you could see the outcome. It turned out to be a negative review. I don't know yet at this time what that word was, but the bag of words, you know, basically accumulates that and keeps that in memory based on the corpus. So, you know, and the corpus basically based on the columns itself. So as you're churning through the bag of words, you kind of get the picture. It's every review that comes in or every new review, it's going to know based on the number of occurrences of that word from all the previous historical data, how many times that word occurred in a positive or how many times that word occurred in a negative review. And based on, you know, how the model's trained and stuff like that, the different combinations of those many different words for that one review, it's going to accumulate all the times that it was positive or negative, and it'll give you a result, whether or not it thinks your brand new review coming in potentially is going to be positive or negative. So that's kind of what's going on here. The course is going to give you a much better description of it. In my example here, my total motivation here is just to kind of give you a high-level overview and kind of not give you a complete detailed explanation so that you'll take the course. So now what we want to do is actually create our training and our test set. So we're going to do split. And so we're actually using, from the sklearn Python library. Let's see what we've got going on here. We've got an error. So why do we have this? Let's see here. It's probably because I think I know what the problem is. So here's the problem. Because I purposely did not include the lab and stuff with all my notes on it, that particular other library is deprecated, so we got to use this one from the Python library, and there we go. So we've got our xtrain and our xtest set right here. So by this test size being 20, this is basically saying your training set's going to be 0.8 because it has to equal to 100%. So by saying test size is 20%, that means your training set is 80%. So 80% of that data is going to be used. You can see it's 800 rows here because it's basically zero base. 80% of our data is going to be in xtrain, and same with in ytrain, because there is a correspondence matching. So that's our ytrain. It's a one-to-one. So what I mean by that is if I bring up xtrain and ytrain, so basically all of these columns up here with all of the words and their counts going across, it equal to a positive review for the first one. And then for the second one, same way across, it was a positive review, and so on and so on. So you're going to also have 800 rows here. If we look at our test set, which is what we actually are going to run against our quote-unquote trained model, our test set's going to have the other 200 rows in it. So as you can see, we've got 200 there, and we also have the 200 right there too. So having said that, now what we want to do is we want to fit the naive Bayes algorithm to the set. So it's actually going to go ahead and do our prediction. So let's go ahead and do that. And now again, I can get into more detail. The course is going to explain why naive Bayes for NLP, but it's a natural algorithm to use. And I can't recommend, again, that course enough. I sound like a broken record. But what we've done right here is we've actually created an instance of that model, which is using Gaussian naive Bayes. And that's a 3D dimensional, shall we say, algorithm. And we're fitting our training set to the classifier, and this is an object of this algorithm. And based on that, what we're going to do now is we're going to create a vector of Y results based on our X test results. So if you look right here, we do not have a Y-pred variable. We do have an X test, but we don't have a Y-pred. Now watch what happens when we do this. Boom. So I'm executing that right there. Now lo and behold, you can see we've got a Y-pred. So it vectorizes the output. So what we've done is we've actually shoved our test set because we actually want to run the algorithm here. So we've shoved these 200 rows right here with a well-known, let's bring up my Y-test. And so here's the well-known output based on our test set right there. And that's our well-known actual output. And this is our computed. So we've trained the model right here. And now what we want to do is we want to take the same thing and we want to say how many times, here's our predicted based on the model, how many times are these accurate right here? And as you can kind of see right here, going through the first couple here, it looks kind of semi-inaccurate, but then again, keep in mind, like row 6 here is the same, 3 is valid. You're not going to have perfect results here. But if my memory serves me right, as we go further on down, it tends to be a little bit more predict, a little bit more accurate. So here on like line 164, you can see that our predicted model predict the value correctly. On 166 it didn't, and 169 it didn't, but in 171 it did, and same with 172. So now you're probably looking at this and you're saying, well, I'm not impressed because there seems to be quite a few inaccurate predictions here. Again, we have a small test set right here. In reality, we'll have a lot more data, and the more data we have, the more accurate things can get. But even so, with a small amount of test data, we can try to figure out how accurate was this given prediction. So by doing that, there's a concept called a confusion matrix. So we're going to go, and again, the Python libraries give you the ability to calculate your confusion matrix. And there is a whole tutorial and things that you can look up online with your confusion matrix and what it's all about. But the long and short of it is, with your confusion matrix, is you can get a metrics of you know, your actual versus your predictive based on your inputs here. So we're actually passing in our test, which is our actual, and our prediction vector, which is our predicted. And the way to kind of read that is you do the diagonal. You do the diagonal. So this is like, this is like the 0 column, which is negative review, and this is the one for the positive review. So the way to read this is you go from top down in this column. This is what we predict. So in total, you know, this is what we actually predicted here. So we predicted like a total of, you know, 67 negative reviews and a total of, you know, 42 plus 91 positive reviews. And then going horizontally, that's our actual counts. So basically out of a total of 67 you know, predicted no's from our model, we actually had an actual of 55 no's. And that was 55 that was correct, and then 12 that was incorrect. And then the same goes for these. This is what the model predicted down for the predicted for positive reviews. We had an actual count of 42 positive reviews right there. You know, well, wait, I'm sorry. I'm getting myself a little bit confused there. So we actually had, I'm sorry. This is the actual number of positive reviews. So we actually had 91 positive reviews from this prediction, and where we predicted it would be 1, we actually had the actual was 12 negative. So that's actually not bad. So the way to kind of read that, is you go through a diagonal. So we had 55. So you could say 55 plus 91, that's 146, and we know that we had like a you know, a total of I believe that's 200. So we could say like 146 plus 42 plus 12. That's a total of 200. So I took the 42 and 12 right there just so that you could see. So if you say 146 divided by 200, we pretty much have an accuracy of 73% on this. And again, in some cases, that's good. In some cases, that's bad. So, you know, you're not going to get, in things like this, you're not going to get 100% accuracy. But what this basically is saying is we've created a model that tends, based on this input data of 800 rows that we trained, which isn't really all that much. It gets more accurate with more. We fed the 200 in. We fed the 200 actual plus the, and got, you know, the list of 200 prediction, I should say. And this model ended up being about 73% accurate. So that's more or less saying 73% of the time when you feed other reviews in with these combinations of words, you're probably going to get the right answer as to whether or not we get a positive or a negative review, based on, you know, using the bag of words model. So I kind of hope this gives you a rough idea of natural language processing and just kind of how cool this particular course is, because this is another aspect of machine learning. So again, thanks for watching this, and I hope you learned a little bit of this. And I do hope you consider buying this course and other things. So have a great one, and thanks again. Bye-bye.